Hi everybody, so today we're going to be doing the Algebra 2 Final Exam Review Category 5 Exponential and Logarithmic Functions and Equations. Let's go ahead and get started. This section is going to cover all things logarithms, exponentials, exponential growth, real-world situations, and being able to write these. So let's go ahead and get started with some actual practice problems. We will sprinkle in a couple other skills here and there to make sure that we kind of keep you guys up to base with what's going on and in preparation for your exam. So this first problem says, which of the following statements are false? And I'm going to underline that word there. It's important that we remember that this is going to be false. We want things that are not true about the graph f of x equals log x shown above. So it says here f of x has odd symmetry. So just a repeat of what even and odd symmetry looks like. Okay, an odd function, okay, is symmetric about the origin. Visually, this means that you can rotate 180 degrees. So if I was to turn this, we would look something like this, right? I turn this 180 degrees. And it should look like the exact same graph. Well, it doesn't. It looks like a reflected version of it. Okay, so does this have odd symmetry? This is false. So we already know that 1 has to be an answer. This one here says, as x approaches 0, so as I'm going to 0, so as I'm going this way to 0, my y value is approaching negative infinity. Okay, so yeah, that is true. Okay, so knowing this, we can already eliminate all answer choices with the number 2, because we're looking for false answers. So B and D are out. And it says on the interval 1 to 4. So 1 to 4 has no relative or absolute extrema. Okay, so extrema, you recall, is kind of like the top of a hill, okay, or the bottom of a pit. This was our max and our min. Okay, so from 1 to 4, we don't have a top of the hill situation, and we're not allowed to use the endpoints as the extrema either. So this is also true. So we can eliminate this, so only 1 is correct here. Okay, and these are just kind of little breakdowns into some properties of this logarithm graph. On this one here, I have a graph of a logarithmic function, and I want you guys to circle all the true statements about this logarithmic graph. So you're going to have to kind of dig into domain and range, look at those intercepts, look at some asymptotes. You guys have the skills to do this. You can draw on this, do whatever you need to do. If you guys have any questions or concerns, let me know. Okay, let's go ahead and move on. This one here, the equivalent form of 10 to the negative 3 equals 0.001. So we're going from exponential to logarithmic form. So you'll recall when we do this, we always change that exponential value with the equal value here. And when we do, we add a logarithm. So log base 10, 0.001 is equal to negative 3. And this is our answer. Okay, so I'm looking for log base 10 of 001. No, this is log base of negative 3. That's no good. Log base of 0, no, that's no good. Log of 0.001. We'll come back to this. And log negative 3, that's definitely no go. Well, what's going on with this one? This is kind of the only choice, but it doesn't have a base 10. So what I want you guys to remember here is that log of base 10 of x is equal to the log of x. That means that if there is no logarithm given, we assume that it is 10. I'm sorry, there's no base given. It is 10. So this is absolutely correct here. It is C. Cool. Let's go ahead and move on. So I want you guys to do the same rule here. Go ahead and rewrite this logarithmic function or equation in logarithmic form. Let's go ahead and move on. This one here says, what is the solution for the equation below? Okay, so when we're doing this one, we're going to have e to the 3x equals 1 over 64. And the issue is I want to get this 3x and I want to bring it down. To do that, we'll have to use the power rule of natural logs. Because remember, natural logs and e's are inverses of each other. ln and e are inverses of each other. In other words, when they multiply with each other, they're going to equal 1 here. And what I do to one side, I do to the other. And this allows me to bring down this 3x. So these simplify out, so I'm left with 3x equals the ln of 1 over 64. I still don't have x by itself. I have this 3, so what I want to do is I want to divide both sides by 3. Simplifies out, so we get x equals the ln of 1 over 64 over 3. And here's our answer. Okay. And so you're probably thinking, sir, what's going on here? Like, why is it that this doesn't match any of these here? So what I want you to do is I want you to plug in this ln of 164, then divide it all by 3, and see which one of these matches up. Hint, hint, you're not going to have to test them all. Start from the top. Okay? Start from the top and see which one matches. That's good practice, as that might be a skill that you'll need for your exam. Let's go ahead and move on. Yeah, so for this one here, I want you to do the exact same skills. So we have e to the 5a minus 2 equals 77.2. You want to isolate the e. So what do you need to do with that minus 2? And then you want to use the ln to bring down the 5a. If you need any help, let me know. Okay, so for this one here, it says, for what value c will the equation 10 to the third root of 2x plus c minus 4 equals 16 have a solution of x equals 3? So with a question like this, it's interesting because what they did is they're just trying to trick you into thinking that there's really more work, but you guys already have all the information to do this. What happens here, okay, is that we have, and I'll work over here, we're going to have 10 to the cube root of 2x plus c minus 4 equals 16. Now, what they want us to do is they want us to solve for c, and you're thinking, well, but I have x, I got to solve for c. Yeah, they give us x. They tell us that x is 3. So we're going to substitute that in here. So we're going to say 10 cube root of 2 times 3 plus c minus 4 equals 16. So then what we're going to do is we're going to add 4 to both sides. This simplifies out. I get 10 cube root, 2 times 3 is 6, plus c equals 16 plus 4 is 20. We then need to divide both sides by 10 because we want to isolate this radical. I'm going to do continue my work over here. So we're going to say the cube root of 6 plus c equals 2. So now I want to get rid of this cube root. To do that, I want to cube both sides. Simplifies out. I get 6 plus c equals 2 cubed. 2 times 2 is 4, times 2 is 8. I still don't have c by itself. I want to subtract 6 from both sides. and I get C equals 2. And we are donezo. So again, this one is just isolating a variable using reverse operations. They just worded it a whole lot differently. Don't let that fool you. Don't let that mess you guys up. Take your time. We've done hundreds of these problems already. So exact same skill on this one. Okay. Plug in the value that you know. The numbers are a little bigger, but nothing you guys can't handle. If you have any questions or concerns, just send me a message. Okay, let's go ahead and move on. So this one here says exponentially growing bacterial colony has a population given of P of t. So I'm already going to start writing that out because I already know that we're going to have to use that. P of t is equal to 4.3 e to the power of 0.013 t, where t is the time measured in minutes. At what time will the population become 4 times as much as the initial population, okay, at t equals 0? Okay, so when we look at this equation, you're probably thinking, how do we get started? Well, this value here, this is our initial, equals 4.3. And they say that they want the final to be 4 times. So the final is equal to 4.3 times 4. Okay? Which is 17.2. So what we need to solve for here is what is the time when 17.2 equals 4.3 e to the 0.013 t. So we have to solve for t here. So to solve for t, we're going to use all the same rules that we did earlier as far as e's and ln's. But first we want to isolate our e. So to do that, I'm going to divide both sides by 4.3. 4.3, these simplify out. 17.2 divided by 4.3, well, we kind of already did that math. We know that's going to equal to 4. Equals e of 0.013 t. I want to bring down this exponent, and I also want to get rid of that e. So we have to use the inverse operation of e, which we've already discussed in this video, is ln. ln of e. These will simplify out. So we get the ln of 4 equals 0.013 t. I don't have t by itself yet. I need to divide both sides by 0.013. 0.013 simplifies out. So I get t equals the ln of 4 over 0.013. And this is our answer in time for minutes. So, that doesn't match anything. Okay. Again, I want you to practice using decimals. Plug this into decimals, ln of 4, divide it all by 0.013, and see which one of these matches. Make sure that you round your decimal off correctly. As you can see, all these numbers are pretty close to each other. So you want to have the correct rounding. Okay. If you have any questions on that rounding, send me a message. I'd rather discuss it than just give you the answer. All right, you guys will have the same work here, except, yeah. All right, let's go ahead and move on. And this one here says, if $900 is invested in an annual interest rate of 7%, which of the following represents the value of the investment after 6 years when interest is compounding continuously? So the interest compounding continuously, typically we see that as some type of P of t equals A naught e to the power of r t. Okay, where P of t is the final, A naught is the initial, r is the rate, and t is the time. So what does all that mean for here? Well, final, they didn't give us the final. That's what we're looking for. The initial, they said, was 900. The rate, they said, was 7%, but we can't leave it in percent. We want that as decimal, so that'd be 0.07. And the time is 6 years. So if we're setting this up, we would say P, oops, not F. Oh, we can just turn that to P. P of t is equal to 900 e to the power of 0.07 times 6. Okay, well that doesn't match anything yet. We see all these like little 42s here. What they did is they multiplied 0.07 times 6. So that would be P of t equals 900 e to the power of 0.42. And there we go. So our answer choice here is letter A. And your last practice problem is this one here. Same scenario. You're going to want to use this exact same equation, just different values. Okay, go ahead and finish this up. If you have, again, any questions or concerns, send me a message on Teams. I'll be more than happy to help you guys out. Best of luck, and we'll see you all later. Bye-bye.